Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to be talking about scientific notation, which is a topic that frequently appears on both the arithmetic reasoning as well as the mathematics knowledge subtest of the Armed Services Vocational Aptitude Battery. More specifically, we're going to take a look at 1. How to write a number in scientific notation, 2. How to go from scientific notation back to standard notation, 3. How to multiply numbers when they're given in scientific notation. 4. How to divide numbers when they're given in scientific notation. And 5. How to approach word problems involving scientific notation. As a few reminders, you're not allowed to use a reference sheet or a calculator on the ASVAB. And in order to get the most out of this video, I strongly encourage you to pause the video as soon as I read a practice problem, attempt to work it out on your own scratch paper, and then resume playing the video to see if you and I came up with the same solution. So all those things being said, let's go ahead and get started with today's video. So as I mentioned, we're going to start today's video by learning to express numbers in scientific notation. Before we do that though, I do want to give you some notes regarding scientific notation itself. First, I want to point out that scientific notation is simply a way to express numbers using a power of 10, and more often than not, scientific notation is used to express very large or very small numbers. And these two examples here, we can see that on the left, we have 7.54 times 10 to the 7th, and on the right, we have 2.8 times 10 to the negative 4th. I want to point out some things regarding these two numbers. First, I want to point out that the number to the left in both instances is always going to be in decimal form. So as we write things in scientific notation, we have to be mindful of the fact that the number all the way to the left is going to be in decimal form. And in addition to being in decimal form, it's always going to be written as a number between 1 and 10. Okay? So in other words, you couldn't have 0.5 times 10 to the 5th. Since this number is not between 1 and 10, it is not in scientific notation. Okay? Another thing I want to point out is that both of these numbers written in scientific notation have exponents. In this case, it's raised to the positive 7th, and in this case, it's raised to the negative 4th. So all numbers written in scientific notation are either going to have positive or negative exponents. If the exponent is positive, that means you're trying to represent a very large number, and what it tells you to do is take this decimal and shift it to the right according to that exponent. So in this case, the exponent's 7, so we would take this decimal and shift it 7 times to the right. In this case, we can see the exponent's negative, so what this says is take this exponent and shift it to the left 4 times, which represents a very small number. So again, positive exponents, large numbers, negative exponents, small numbers. All right, so here's all the steps to write a number in scientific notation. First, you want to locate the number's decimal point, and in some cases that's not so obvious to do, so we'll get practice doing that. Then you want to move it to a location that will give you a number between 1 and 10, or exactly 1. And I mentioned previously that that's going to be the case. Then we're going to write the number down, followed by times 10. And we're going to count how many times we had to move the decimal place. And we're going to use that number as our exponent. Finally, we're going to decide what the sign of our exponent is going to be. If it's a large number, the exponent's going to be positive. And if it's a very small number, the exponent's going to be negative. So with those things in mind, let's go ahead and get practice doing this. So in this case, we have 3,500,000. And we want to express it in scientific notation. The first step, as you may recall, is to locate its decimal. As it turns out, when you don't see the decimal in the number, it's always at the very end of the number. So there's the decimal. Then we want to take that decimal and shift it however many times we need to make this number between 1 and 10. So let's do that. That's going to be 1, 2, 3, 4, 5, 6. Okay? Then we're going to write down that number, which is going to be 3.5. We're going to multiply it by 10, and we're going to raise it to either a positive or negative power according to how many times we had to move that decimal. And in this case, we know we're dealing with a large number, so we know it's going to be positive, and more specifically, it's going to be positive 1, 2, 3, 4, 5, 6, since we had to move the decimal place 6 times to make 3.5 million be 3.5. Okay, and that's all there is to it. Let's go ahead and do another example, and at this point, I encourage you to work out these problems on your own. Again, we want to take the number 0.000467 and express it in terms of scientific notation. The first step is to locate the decimal, and thankfully this one's pretty easy to see, given that it's in the number itself. Then we're going to shift it however many times we need to write this number as a number between 1 and 10. So that's going to be 1, 2, 3, 4. We can see that number is 4.67, which is in fact between 1 and 10. I'm going to multiply it by 10. And since this is a very small number, we know our exponent's going to be negative. And more specifically, it's going to be negative however many times we had to move the decimal place to write this 4.67. That's 1, 2, 3, 4. So this is 4.67 times 10 to the negative fourth. All right, let's work on number 3 now. We can see we have this number, 0.0000506. Again, we want to express it in terms of scientific notation. First step is to locate your decimal. Thankfully, that's pretty easy in this case. Then we're going to shift it however many times we need to make this become a number between 1 and 10. So that's going to be 1, 2, 3, 4, 5, 6 times. We'll write that number down, 5.06 times 10. Since this is a very small number, we know our exponent's going to be negative. More specifically, it's going to be negative however many times we had to move this decimal. Again, that was 1, 2, 3, 4, 5, 6. So this is 5.06 times 10 to the negative sixth. So as you can see, we have to express this number in scientific notation. It's going to be 8, 3, 0, 4, 0, 0, 0, 0, 0, 0, 0. If I'm not mistaken, this is 83,040,000,000. Okay, so let's write this in scientific notation. The first step is to identify our decimal, which is right here in this case. We're going to shift it however many times we need to make this a number between 1 and 10. So let's go ahead and do that, and we'll keep count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to write that decimal that we just created. That's 8.304. Again, that's times 10. And we move this decimal place 10 times. And since this is a very big number, we know that that exponent is going to be positive. So that's how you would do that one. And finally, let's do number 5. We have 446.2. We want to express it in terms of scientific notation. Locate the decimal as our first step. We can see it's right there. Shift the decimal however many times you need to in order to make this number between 1 and 10. So we're going to have to shift it 1 time to the left. So this is going to be 4.62 times 10. And in this case, we shifted the decimal 1 time. So this is 4.62 times 10 to the 1. and that one is now written in terms of scientific notation. Okay? All right, so now that we know how to write numbers in terms of scientific notation, let's discuss how we go from scientific notation back to standard notation. And it's a pretty straightforward process, thankfully enough. First, you want to use the exponent to determine if the number is large or small. Again, positive exponents, large numbers; negative exponents, small numbers. Determine which way to move the decimal point. As I alluded to earlier, if the exponent's positive, you're moving it to the right. If the exponent's negative, you're moving it to the left. Move the decimal point the number of times the exponent says to, and then write the number you now have. So let's go ahead and get some practice doing that. In this case, you can see that we have 4.59 times 10 to the 7th. So we have 4.59 times 10 to the 7th. Well, again, right away, we know this is going to be a big number because the exponent is positive. And since the exponent is positive, we know we're going to take this decimal and shift it 7 times to the right. So that's going to be 1, 2, 3, 4, 5, 6, 7. Fill in your zeros as needed. That is not a good zero there, so fill in your zeros as needed. And then if it's helpful, you can rewrite the number using commas. So this is 4, 5, 9. How many zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Add a comma after every third place. So that's 1, 2, 3 there, 1, 2, 3 there. So we can see that this is 45,900,000. Okay. Let's do the same thing for number 7. Let's go ahead and write down 2.14 to start, since we know we're going to be shifting its decimal. According to this exponent, since it's negative, we know we're going to be shifting it to the left, and this number is going to be very small. More specifically, we're going to shift it 3 times to the left, so that's going to be 1, 2, 3. Fill in our zeros as needed. So we can see that this number is 0.00214. All right, let's do a few more practice problems just to make sure we have the hang of this. We have 5.01 times 10 to the negative 5th. In light of the fact that this exponent is negative, we know we're shifting this decimal to the left 5 times, which would mean this is a very small number. So 1, 2, 3, 4, 5. Add in your zeros as needed. So we can see that this is 0.0000501 in terms of standard notation or standard form there. All right, 3 more practice problems to make sure we understand what's going on here. We have 8 times 10 to the 8th. In this case, it may not be obvious, but the decimal place is right there. And this 10 to the 8th tells us we're going to move the decimal place to the right 8 times, which means this is going to be a very big number. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. Fill in your zeros. And we can write this using commas to make it look nice. There's 1, 2, 3, 4, 5, 6, 7, 8 zeros. So this is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Add your comma after every third place. 1 there, 1, 2, 3, 1 there. So we can see that this is 800 million. Okay. For number 10, it says to write 2.97 times 10 to the negative 2 in standard form. So we have 2.97. According to this exponent, we're going to take this decimal place and shift it to the left 2 times. 1, 2. Fill in our zeros as needed. So this is 0.0297. And finally, we have 4.25 times 10 to the 11th. So that's 4.25. This exponent which is positive, tells us we're going to shift this decimal 11 times to the right. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Add our zeros in as needed. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So this number is 4, 2, 5, and then 9 zeros. 2, 3, 4, 5, 6, 7, 8, 9. Fill in your comma after every third place. One there, one there, one there. So this is 425 billion. All right, now that we've done instances where we had to go from scientific notation to standard notation and vice versa, let's try to do both things at once. Again, if you're following along at home, this would be a good time to make an effort to pause the video and try to work these out on your own. And again, in case it's not obvious, we have this chart here, and on the left we have scientific notation. And on the right, we have standard notation. So if you want to draw a line right here, you can. And basically, we're going to write things. We're going to fill in this chart as needed. So in this first example, we're given something in scientific notation, and we want to write it in standard notation. So I'm going to write down 3.409 over here. I know that this 10 to the negative 3 tells me to shift its decimal place 3 times to the left. 1, 2, 3. Fill in my zeros. I'm going to need 2 in this case. So this is going to be 0.003409. Okay, now we're going to have to go from standard notation to scientific notation. The first thing I want to do is shift this decimal however many times I need to make this number between 1 and 10. So that's going to be 1, 2, 3, 4, 5, 6. So this is going to be 5.81 times 10 to the negative 6th. Okay. All right, in this case, we're going from scientific notation back to standard notation. So let's write down 9.1 over here. And this 10 to the 4th says we're going to take this decimal and shift it 4 times to the right. 1, 2, 3, 4. Fill in our zeros as needed. 1, 2, 3. So we can see this number is 91,000. Now we want to go from standard notation to scientific notation. Again, we have to locate the decimal as our first step. If you don't see it, it's always at the very end of the number, so it's right there in this case. Then we want to shift this decimal however many times we need to write this as a number, a decimal between 1 and 10. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this is going to become 9.081 times 10 to the, and that was 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Okay, so that's that one. In this case, we want to go from standard notation to scientific notation. Again, we want to locate the decimal. It's right here. We want to shift it such that it becomes a number in decimal form between 1 and 10. So we want to shift it 1 time to the left. This is going to be 2.758 times 10 to the 1. All right, let's go from scientific notation to standard notation. Again, I'm just going to copy over 1.54 over here. And this 10 to the negative 5th tells me I'm going to take this decimal, which is right here, and shift it 5 times to the left. 1, 2, 3, 4, 5. Add in our zeros accordingly. There's going to be 1 there, 1 there, 1 there, and 1 there. So this is 0.0000154. All right, let's go from standard notation to scientific notation. And this one's pretty tricky because it's already written as a decimal between 1 and 10. So this is going to be 5.31. How can we represent this times 10 such that it doesn't move this decimal? Well, we can write this as 10 to the 0. Anything raised to the 0 power is just 1. So this, in other words, is the same thing as 5.31 times 1, which is just 5.31. Okay, so just keep in mind that 10 to the 0 is the same as 1. All right, let's go from scientific notation again to standard notation. We have 6 times 10 to the 5th. Again, the decimal's right here if you don't see it. And this positive exponent of 5 tells me I'm going to shift its decimal 5 times to the right. So this is going to be 1, 2, 3, 4, 5. Fill in your zeros. You can see there are 5 zeros. So this, of course, is 600,000. All right, let's go from standard notation to scientific notation, our standard form. And in this case, we can see we're gonna have to shift the decimal 1, 2, 3 times to make this a decimal between 1 and 10. More specifically, that's going to be 7.009 times 10 to the 1, 2, 3, 10 to the negative third. And finally, we have 4 times 10 to the 0. 10 to the 0 is just 1, so this is 4 times 1 are just 4. All right, so now that we've taken a look at some very basic examples, let's go ahead and discuss how to multiply and divide with scientific notation. If you expect to score somewhere between 75 and 99 on the ASVAB, you may encounter problems of this nature. So that said, let's take a look at a few examples of each of those. And thankfully enough, this is pretty straightforward. On this first example, we're being asked to evaluate the expression 1.3 times 10 to the second by 2.5 times 10 to the first. Off to the side, I'm going to rewrite this using x instead of that dot there. So this is 1.3 times 10 to the second times 2.5 times 10 to the first. Okay? And the way to approach this problem is to group up your decimals and your powers of 10 with each other. And we can do that using the commutative and associative properties. So what that enables us to do is, as I mentioned, just group these up. That is 1.3 times 2.5 over here. And then 10 to the second times 10 to the first over here. 1.3 times 2.5 is simple arithmetic. That's going to be 2.5 times 1.3. That is, we're doing multiplication with 2 decimals. In order to do this by hand, we have to shift the decimal to the right such that it makes the decimal a whole number. So I'm going to have to shift the decimal in 2.5 one time to the right to make 2.525. Again, I'm going to have to shift the decimal in 1.3 likewise one time to the right to make 1.313. So in reality, I'm doing 25 times 13, albeit with 2 decimals that I have to shift back into the left at the end. One when I shifted it in 2.5 and the other when I shifted it in 1.3. So let's go ahead and work this out very quickly. This is 5 times 3, which is 15, carrier 1. 2 times 3 is 6, plus 1 is 7. Add a 0 before you start multiplication with this 1. 1 times 5 is 5, and 1 times 2 is 2. Let's add. 5 plus 0 is 5. 7 plus 5, 7, 8, 9, 10, 11, 12. Carrier 1. 2 plus 1 is 3. Add our 2 decimals back in, so that's 1, 2. So we can see that 1.3 times 2.5 is 3.25. Now we have to deal with this side of the parentheses, that is 10 squared times 10 to the first. And in order to do this, we're going to have to know the product rule, which is one of the laws of exponents. It's specifically number 1. As you can see, law 1 says a to the n times a to the m equals a to the n plus m. That's exactly what we have here. We have 10 to the second times 10 to the first. That is, the bases are the same. So what we do in this case is we do 10 to the 2 plus 1. That is, we add their exponents. So this becomes 3.25 times 10 to the third, which is the same as 3.25 times 10 to the third, which is now written in scientific notation. So this may suffice as an answer. That said, if we wanted to write this in standard notation, we would have to realize that we take this decimal and shift it 3 times to the right, given that the exponent is positive 3, so 1, 2, 3, add a 0 in. So in standard form, this is 3,250. So both of these answers would be correct. And that's all there is to multiplication with scientific notation. It's pretty straightforward. Group your decimals together, do that arithmetic. Group your powers of 10 together, use the laws of exponents, which means you're just going to add the exponents, and then just write it in scientific notation or standard form as needed. Let's take a look at an example in which we have to now do division with scientific notation. And before we get started, let me just mention the quotient rule involving exponents. Let's say we had a to the m divided by a to the n. This would be the same as a to the m minus n. We're going to make use of that when we do this division now. So for this example, you can see that we have to evaluate the expression 9.45 times 10 to the 6th divided by 2.1 times 10 to the third. So again, this is 9.45 times 10 to the 6th divided by 2.1 times 10 to the third. So as we did above, we're going to group up our decimals and our powers of 10 accordingly. That is, I'm going to break these up into 2 sets of parentheses. In this first set, I'm going to do 9.45 divided by 2.1. And in this second set, I'm going to do 10 to the 6th divided by 10 to the third. Okay, so in this case, we have to do this long division with decimals. That is, we're going to have to do 9.45 divided by 2.1 to figure out what this is. And let's go ahead and work on that. As far as doing long division in decimals goes, you can do it as long as there's no decimal outside this division bracket. In this case, we can see we have 2.1 outside the division bracket. So what I'm going to have to do is shift this decimal in 2.1 one time to the right to make 2.1 21. And then I'm going to have to shift this decimal in 9.45 a corresponding number of times. So I'm going to shift it one time. So in reality, I'm doing this. 94.5 divided by 21. Now we can proceed. Again, it's okay to have a decimal inside the division bracket, but you can't have a decimal outside the division bracket. And now we can just bring up this decimal in place as needed. I'm going to round this to 20 just to see what this is going to be. 20 times 5 would be 100. 20 times 4 would be 80. So I know the most 21 is going to go into 94 is going to be 4 times. So let's do that off to the side to see what it is. 4 times 1 is 4. 4 times 2 is 8. So 21 times 4 is 84. Let's subtract. 94 minus 84 is going to be 10. Let's drop down this 5. And now the question is, how many times does 21 go into 105? That's going to be 5 times. And if you need to, you can work this one off to the side. 21 times 5. 5 times 1 is 5. 5 times 2 is 10. So we can see that 21 times 5 is exactly 105 with no remainder. Therefore, we know 9.45 divided by 2.1 is 4.5. Okay? Now we got to deal with this right-hand side of the parentheses, that is 10 to the 6th divided by 10 to the 3rd. Well, if we take a look at this quotient rule, which is one of the laws of exponents in that chart I mentioned previously, as long as the exponents have the same bases, we can subtract their exponents. In this case, 10 is the base for both of these. So all we're going to do is take 10 and do 6 minus 3. So this becomes 4.5 times 10. 6 minus 3 is 3. So this is the same thing as 4.5 times 10 to the third. And there it is in scientific notation. Again, if you wanted to convert it to standard notation or standard form, that'd be pretty easy. You would just take this decimal and shift it 3 times to the right. Okay? So those are the only examples I'm going to do involving multiplication and division. It's pretty straightforward. Again, as long as you follow these steps and are mindful of both the product rule as well as the quotient rule when you deal with your powers of 10, these are pretty simple to solve. All right, now that we've looked at how to write numbers in scientific notation, take those numbers that are written in scientific notation and express them in standard form, do multiplication and division with scientific notation, let's go ahead and take a look at some word problems involving scientific notation. Again, scientific notation is a topic you might see on both arithmetic reasoning as well as the mathematics knowledge subtest. And if it's going to be on the arithmetic reasoning subtest, chances are it's going to be given to you as a word problem. So let's make sure we can deal with a couple of those variations. As we can see, question 1 says, Mr. Griffin's class is studying the solar system. The circumference of the Earth at the equator is about 24,900 miles. Express this number in scientific notation. Okay, so again, we're given the number 24,900, and we want to express this rather large number in terms of scientific notation. Again, the first step is to identify the decimal. Since it's not obvious as to where it's at in this number, it's always going to be at the end. Then we're going to shift this decimal however many times we need to make this big number a decimal that's between 1 and 10. So we're going to shift it 1, 2, 3, 4 times. And as we can see, that new number is going to be 2.49. That's going to be multiplied by times 10. And this exponent corresponds to how many times we had to shift its decimal. Again, 1, 2, 3, 4. So this is times 10 to the fourth. And that's all there is to this first problem. All right, number 2 says the SR-71 Blackbird is one of the world's fastest airplanes. It is capable of traveling at a cruising speed of Mach 3, or 3 times the speed of sound. The speed of sound is approximately 7.6 times 10 squared miles per hour. What is Mach 3 in miles per hour? Write your answer in scientific notation. All right, so there's a few things going on in this problem. We're given information about an SR-71 Blackbird, as well as the speed at which it cruises. More specifically, we're told it cruises at Mach 3. And we want to figure out how fast that is when we're only given the value of Mach 1. So let's go ahead and write down what Mach 1 is. According to the problem, Mach 1 is 7.6 times 10 squared. So again, this is Mach 1. And we're going to use this Mach 1 speed to figure out how fast Mach 3 is. And then we'll take that number and convert it to scientific notation. In this case, it's pretty easy to work this out. Again, this says 7.6 times 10 squared. Since this is positive, that tells us we take this decimal and shift it 2 times to the right and add a 0 in. In other words, Mach 1 is the same as 760 miles per hour. To find out how fast Mach 3 is, all we're going to do is take this 760 miles per hour and multiply it by 3. So that's going to be 760 times 3. 0 times 3 is 0. 6 times 3 is 18. Carry your 1. 7 times 3 is 21 plus 1 is 22. So we can see that Mach 3, which is right here, is approximately 2,280 miles per hour. Again, the problem wants us to write this in terms of scientific notation. So again, we have Mach 3 is 2,280 miles per hour. To write a number in scientific notation, we first find its decimal. Its decimal's right here. We shift it however many times we need to make this number a decimal. That's between 1 and 10, so that's going to be 1, 2, 3 times. So we can see that is 2.28 as a decimal. Multiply it by 10, and this exponent corresponds to how many times you had to shift its decimal. 1, 2, 3 in this case. So Mach 3, which is the cruising speed of this SR-71 Blackbird, is approximately 2.28 times 10 to the third miles per hour. Okay? Right, so finally, as we can see, number 3 says, the population of the United States is 3 times 10 to the 8th, and the population of the world is 9 times 10 to the 9th. How many times larger is the population of the world than the US? Okay, so to solve this one, we're going to take the population of the world, which is 9 times 10 to the 9th, and we're going to divide it by the population of the United States, which is 3 times 10 to the 8th. And just a few minutes ago, I showed you how to do division involving scientific notation. That is, we can group up these numbers in one set of parentheses. That is, we can do 9 divided by 3 over here. And then over here, we can group up our powers of 10. That is, we can do 10 to the 9th over 10 to the 8th. And now all we do is have to solve these separately. 9 divided by 3, we should know, is going to be 3. And then for this, we have to know the quotient rule, which is one of the laws of exponents I mentioned earlier. Again, that's a to the m over a to the n equals a to the m minus n. As you can see, that's what we have in this case. We have the base of 10, which is the same in both cases. We have m as 9 and n as 8. So all we're going to do is take this base, write it down, and then subtract the exponents. That is 9 minus 8. So this becomes 3 times 10 to the 9 minus 8, which is 1. Again, this is the same as taking this decimal, which is right here in 3, and shifting it 1 time to the right and adding a 0. So in other words, the population of the world is about 30 times bigger than the population of the United States, according to the numbers given in this problem. In reality, that number is probably much different. All right, so that's it for today's video. Admittedly, we covered quite a bit of ground. Again, just to recap, we learned how to write a number in scientific notation. We learned how to go from scientific notation back to standard notation. We briefly looked at the process to multiply and divide numbers that are given in scientific notation. And we took a look at a few examples of some word problems involving scientific notation. I hope you found this video helpful. If you like the content that I'm creating, please consider subscribing to my channel. As I mentioned in a community post, in about 2 weeks, I'll have covered all the topics that are going to appear on all the math topics on the ASVAB. So be sure to subscribe so you don't miss any of those upcoming videos. You're more than welcome, as always, to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.